Hey now, what's up, party people? We're gonna do some Code Katas. Head over to codewars.com. We're doing them in order. We are on which one are we on? We had started this one last time in the last video. So we need to validate our ATM machines allow 4 6-digit PIN codes. The PIN codes cannot contain anything but exactly 4 digits or exactly 6 digits. If the function is past the valid PIN string, return true, or else return false. Cool. So we've already put it in our folder. We just need to open it. Grab our function. And let's grab our tests. So we have a ton of tests. Let's just grab like three ones or 4 that should return false. And we'll grab 4 that return true. That should be enough for our purposes. Okay. Let's grab 4 that should return true. Get Quokka started up. So we're getting undefined return, that's good. So I think what we're gonna have to do is we're gonna have to use some regex. So we'll create our regex. Then let's then we'll test it against the pin that we're passed in here. So let's go ahead and we're gonna return this from the get-go. I happen to know, because I've already played around with it a little bit when we were trying to do it yesterday. Some of the tests will have will be negative, or they'll have decimals and stuff at the end. So we're gonna go ahead and do we want it to start with and end with, and we'll do our other calculations in between here. And what we're gonna end up testing this against our pin, so we could go ahead and test against our pin like that. So we need to test against we need numbers, right? So so the shorthand for getting numbers is D. So we could do that, and that's the same as 0 through 9, like that. So we'll go ahead and \D, and we want to specify like a length, and I think okay, so since we're checking, so this is what we want right here. This will tell you how many of a certain character. And right now we're just checking numbers. So what we want to say is we'll check 4 first, like that, right? And then so that checks for 4. It checks for only numbers, and we want 4 numbers. The next thing we want to do is we need to do the same thing, but we need to do it for 6. So we'll check our numbers again, and this time we want it to be, we want to check for 6. And that should do it. False, 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 true. Out. We're failing for 1. It's 5 characters. Oh. I think we need to put this in quotes, or in parentheses. There we go. Cool. So let's throw it in Code Wars and see what happens. Let's test it out. Attempt. Nice. Cool. So we're starting at the beginning of the string. We're checking for our only numbers. We want there to be a length of 4, or check for numbers length of 6, and then all the way to the end of the string, and then we'll test it on our pin that we're passed in. So let's go ahead and submit. Let's see what other people's solutions are. So exactly what we did. Pin length is correct length. It checks if it's either 4 or 6, and then it matches. Same way we did. So it checks if it's the correct length, checks if it only has numbers, returns true, or else it returns false. Same thing we did, same thing we did. Regex, same thing we did. They used the brackets with the numbers instead of the /D. Then they tested it. Cool. Let's keep it rolling. Binary addition. Let's go ahead and actually, let's come over here. Let's save this. Let's get rid of it. Save this. Let's get rid of it. So what we want to do, we need to implement a function that adds two numbers together and returns their sum in binary. This conversion can be done before or after the addition. The binary number returned should be a string. Cool. So let's do it. No. Bring our function in. Let's bring our test in. Okay, well, I mean, I think this should be pretty easy. Our tests, they don't really give us test. It should return something falsy. Test it should return, oh, it should return 11. Is that what's going on here? So we have one test, I think. And I think what we're expecting is 11. So let's go ahead and get Quokka up and running. So I think what all we need to do is return A plus B, and then how do you change a number to binary? It was a bitwise kind of thing. So toString, can you pass in the number 2, and that should do it for us. In order to do that, we're gonna have to put this in quotes, and then we'll say to string, we pass in 2. And look, 11, 11. How about that? Cool. So let's pass it into Code War, see what happens. Test. Nice. Let's attempt. Cool, dude. I don't know how this works. You will shift your number 0 bits to the right. That's the bitwise. Here is the explanation. Two is the Regex. And it can be any base between 2 and 36. Interesting. Okay, cool. Cool. Let's submit it. So, if we look and see, they did the same thing we did. They used the bitwise. They created a function. A plus B result to a string, while C is greater than or equal to 1. Math.floor. Okay, cool. Sum of odd numbers. Uh-oh, this looks crazy. Given a triangle consecutive odd numbers, calculate the row sums of this triangle from the row index starting at index 1. If we get 1, we get 1. Oh, so they're giving us the row. So row number 2 is 3 and 5, and that equals 8. Okay. I think we can do this. Maybe. Whoa! Did not want to do that. Wanted to do that. Let's bring our function. Let's grab our test. Quaka. Drinking some lemonade. So how are we gonna do this? So they're giving us 42. We get 74,088 back. So our row 1, so they give us 1 over here. Sum is 1. Row 2, sum is 8. So row 2, we get 8. Row 3, what's the sum of our row 3? So 11, 9, 7, 27. So 2 times, let's get the sum of row 4. I think I know what's going on here. 19 plus 17 plus 15 plus 13. Nice. Okay. So I noticed that 2 to the 3rd power equals 8. The sum of our 3rd row was what? 3 to the 3rd power. It's going to be 27, right? Isn't that what we got? 11 plus 9 plus 7. So we get 27. And it worked for our 4th row as well. So I'm thinking all we need to do is return math.pal. Then we need to pass in the number they give us, which is n, I believe. Yep. And we want to do it to the 3rd power. And check that out. 74,088, 74,088. Cool. Here is, let's test it. Got it. Submit. So let's check it out. Did the same thing. N times n times n, which is the same thing. N to the 3rd power. Here's the new operator where it gives us the power instead of using POW. Okay. Playing with digits. Some numbers have funny properties. For example, 89. 8 to the 9th power, or 8 to the 1st power, plus 9 to the 2nd power equals 89. And that times 1 equals 89. 6 to the 2nd power Why are we starting with the 2nd power? 4th power. Oh. Okay. So given a positive integer n written as a, b, c, d being digits in a positive integer, we want to find a positive integer k if it exists, such as the sum of the digits of n taken to the successive powers of p is equal to k times n. In other words, is there an integer k such as I don't know what any of this means. Let's check out our So the second number is the power that we're going to start out with our first digit, it looks like. Because here it's 3, and we start out with 4 to the 3rd power. Here it's 2, we start out with 6 to the 2nd power. So turn 1, since 8 to the 1st power plus 9 to the 2nd power equals 89. (89 times 1 equals 89. 6 to the 2nd power, 9 to the 3rd power, 5 to the 5th power gives us 139. 1,390. 695 times 2 gives us that 1390. So we return 2. So we could get our sum and then divide it by our original number, and that should be the number that we return. And if you look at this example, we would get a decimal returned. So we return -1 since it's going to be below 0. Okay. Let's try it out. Playing with digits. And look at this, I've never even done this one before. This is the first one I've truly never done before that I've done on video. Well, all the other ones I haven't done in a million years, but so it's pretty much like I've never done it. But this one I've really never done. Let's bring our title in. Let's grab our function. Okay. So we're gonna need to split our number, loop over it, put it to the correct power, we can put them in an array, reduce our array, divide our array by the original number, and that'll give us our answer. And if the sum is less than 0, then we need to return -1. Cool. So let's have a place to store our numbers. We'll call it equation. Give me 1 second, I'll be right back. Okay, so that's where we'll store our equation. We also need to split our numbers, so we're going to go ahead and let n, we'll say n equals n dot 2. We need to turn it into a string before we can split it. Dot split. We want to split it like that. And then we want to, right now it's an array of, if we log right here, you can see it's an array of strings. So we want to turn each of those to numbers. So what we can do is we can map over. Or you know what, could we do, no wait, this wouldn't work, would it? If we just put our plus sign there? Not, okay, no. So we need to, we're gonna map over. We'll take our num. And we'll say num. And that'll turn each of them into a number. Now they're not strings anymore. So that's our array of numbers. So we're going to need to loop over that. So let's start our for loop. We're going to let I equal, we want I to equal P. P is the number that we start out with on our first digit. So I is going to equal P. While we're going to let I equal 0. And we'll let, how do you put two different variables in a for loop? Then what we want to say is while I is less than n.length, we want to increment it so we can loop through our array. But we need a variable to store our power, and we need to increment our power as well. Two variables in a for loop. I know there's a way to store two different variables. So you just do it with a comma. And then we can do two, we can increment also at the end with a comma. So we'll let P will equal, or we'll say power. And then we'll do comma, and we'll say power plus plus also. So then we'll say equation dot push. We want to push our number. We want to push and right here we'll go ahead and let we'll let number equal in at index. So we want to push did we not spell equation right? We did not. We want to push math.pal our number, and we want to push it to power. So then let's go ahead and log our equation, see what we're getting. Cool. So now we need to reduce our equation. So we'll say return. Well, we don't want to return yet. We'll say let sum equal equation dot reduce. We'll take in our accumulator and our num. We want to say accumulator plus equal num. So let's log sum, see what we're getting. Cool. And let's go, we can go ahead and divide it by our original number, which is n. Not a number. Why? Why would that be not a number? Okay, let's do sum divided by n. What is sum? Is sum a string? It's a number.
Big hand. I like the future. I know it. Build it myself and I love it. I'm not sure. Personally, I'm very pleased. It'll be alright. I continue.
Oh, because we changed into the freaking array. Oh, of course. So that's a problem. So we'll go ahead and let this be num array. And this needs to be num array. And this needs to be num array. Okay, cool. So now, if we divide by the original number, cool. So now we'll do an if statement. We'll say return if sum is greater than 0, we want to return sum, else -1. Oh, so this is greater than 0. What are we trying to do? If sum is greater than 1, are equal. Okay. I think we did it. Let's test it. Let's hope for no errors. Feeling pretty confident. Test. Attempt. So I could just test if sum can we do it like this? If sum is not equal to I think that we need to check for a whole number. These are from 2013. I know there's a better way. So what do we need to do? So we need to test it against math.floor. If sum is equal to okay, let's test this out. I think this still won't work if it's nice. So that solved it. Cool. That was fun. Let's submit it. Let's see how other people did it. All right. So They stringed it, split it, reduced it to the power. The number, index. Return -1. Or else return the sum divided by the original number. Mapping over. Crazy solutions. Index equals 0. I don't know what's going on there. Alright. Well, I think that's enough for today. Thank you for watching. Hope you have a great day. Peace.